Okay, guys. I think we can slowly start. Welcome on the final keynote. Please take your seat. There are plenty of seats available, so just look around. And even in the front rows, we've got some seats available, so please come and join us for the final keynote. We are starting right now, so hopefully everybody feels comfortable right now. And let me start. Let's jump to the subject. So good afternoon and welcome back for those who are joining my session again. So I've been delivering the one just 2 hours ago. So welcome back. And if you were not there, then absolutely welcome on the final keynote for the conference. Let me first introduce myself and then I will tell you, of course, what we're going to be talking about. So, first of all, as you can see on the slide, my name is Paula Januszkiewicz, and I have to do a little bit of a savoir-vivre to introduce myself, of course. As you can see, I'm the CEO of Secure. This is the company that I have established 13 years ago. We are right now placed in 4 locations, so New York, Dubai, Zurich, and Poland. It sounds very big, but for real, our team isn't that big. It's growing, of course, especially from the last year and the previous year. You had a chance to attend the conference. Right now we are approximately 50 people. I'm saying approximately because we are in the current process of hiring someone, and let's see if that works out. But anyway, so this is the background, which also proves the point that when I was establishing a company, I was the only person, and I would never predict that cybersecurity will grow that much. It has been always a fascinating subject, but definitely nobody would predict that cybersecurity is going to be in minds and hearts of everybody that is even not related with technology. And everybody's concerned about their data privacy. Everybody's concerned about the security of their private desktops. Therefore, this is also what we're going to be talking about, that everybody, even my grandma, we are all surrounded by hackers. And the question is, what can we do about it? So what this session is about. First of all, my background is pretty straightforward. So why this is me actually talking about the cybersecurity skill set, so how we are able to expand it, what kind of things we should know for the upcoming year. I would put it very straightforward. I had a chance to be in the cybersecurity field for so many years right now. And the thing is that what I've been doing pretty much for my whole life, it's penetration testing and also incident response and forensics. And especially within the last 2 years during the pandemics, forensics and incident response were definitely on the rise from the skill set perspective. And what we've learned is that as a team, and even as myself, is that pretty much that is the skill set that is quite often missing within the companies. But is there anything else? Is there any other skill set that we should know, to invest into, to know definitely for sure, so that it can help us out within the upcoming year? For sure. And this is also the background for the presentation. If it's about my speaking experience, then I would like to give you just a little bit of a background. As long as, of course, there is someone to listen about cybersecurity, that makes me super happy. But from the tools perspective, from the presentations perspective, I also had a chance to speak at various black hats, because within our team, we discover certain vulnerabilities, right tools, and so on, and also delivering the keynote at the RSA in San Francisco. And that's also quite interesting for me as well, because it has been always more business focused from the RSA perspective, but now they are actually focusing so much on cybersecurity and also on the practical side of it, that it also shows us the direction how and where the cybersecurity is moving into. So we're going to talk about the skill set that we need to get in order to be up to date for the 2022. And I really like to have the very interacting session, especially from the keynote perspective, where we've got a little bit of more relaxed atmosphere over here. So if you guys have any questions, some comments and so on, please do interrupt. And it's always good to have a conversation. So we are able to see what is happening now, or what's going to happen to the Netherlands at 7 p.m. today, because I guess all of you are expecting the interesting news. And that's not only Netherlands. As I followed the news after I heard about you, I was like, okay, what about the other countries? And lots of countries are getting into this phase where we're going to be experiencing various lockdowns. These lockdowns and also various announcements, we can see that they are directly impacting, obviously, not only our lifestyles, but also the situations that are happening within the cybersecurity. So if, for example, I will be a hacker, one of the things that I would rethink right now is to send a massive campaign to everybody in the Netherlands announcing the new rules of a lockdown. And that would be a great phishing that I believe that lots of people would definitely fall for. Because this is what we are afraid of, this is what we are expecting, this is what we want to know. So these kind of events are very much used by the hackers nowadays in order to get into the infrastructure. So the question is, what kind of approach we should take? And that kind of announcement, that kind of news, were started, by the way, by the CISA, which is actually the cyber agency for the Department of Homeland Security, where at the very beginning of pandemic, so you can see the date, March 6, 2020, where lots of countries were getting into the serious lockdowns, they were actually making this announcement that, hey, pandemic is coming, and basically, you need to have a high-end approach to cybersecurity because there is a risk of increased phishing, of increased attacks, increased vulnerabilities being discovered. So in general, companies, you all watch out because it's starting. Yeah. So that was the message. But obviously, they were not the only ones. Now, whenever we are seeing and summarizing how pandemic impacted cybersecurity. So after that, we've got 1 year that passed, and then the question is what happens. Here we've got statistics that were actually shared by FBI when they said that there is this number, which is 300% of attacks, where the attacks have increased during, of course, the pandemic. And is this a lot? Obviously. It's quite a serious number. So interesting fact is that Interpol, doing the international investigation about the increased attacks, they actually say a higher number. They say that attacks have increased by 569%. So this is also a drastic number. So that also shows one simple thing, that we could be thinking, does it mean that attacks are more sophisticated? And the answer is no. It's just that we've got more of those, and they are hitting more of the companies that somehow were living without really securing themselves and some kind of avoiding that attack sphere, and they were not becoming targets. Now everybody is a target, and basically if you manage to eventually encrypt some data at the side of a certain company, then you can, as a hacker, earn a little bit of more money. And that is a great opportunity to earn. Do you guys know that successful ransomware campaign gives us the income of $90,000 per month? It's quite a nice salary. Definitely very lucrative business to step into. For lots of people, it's tempting, especially the ones that have no maybe perspectives, and they were like, what am I supposed to do? Why don't I just do this and that? And you send 100,000 emails, 1% of people pays, and then you're already secured for the next month. So unfortunately, when we think about investigation or international investigation of hackers doing that kind of activities, it's still not in a good position. So it's a very good momentum for everybody being on the bad side to actually hit you in order to get some income. Now, when we summarize 2020, unfortunately, I don't have statistics for 2021 because this year it's not over yet, but Verizon Data Breach Investigations report, which is actually one of my favorite reports, summarizes that 17% of breaches were caused by outsiders. In the other reports, you are able to see that phishing is a #1 mean of transportation for malware, and it's actually a #1 threat to the companies. Okay, so we can connect the dots over there. And then we've got 86% on the right side that's claiming that these breaches were just simply financially motivated. So not a surprise, I would say, that whenever we still connect the dots, we can see that phishing is the point of entry, password spraying is a point of entry as well, as the history shows. And also we see the situations of a human-controlled ransomware And that is also quite an interesting statistic that's published by the James Comey, former FBI director. By the way, one of my favorite guys, to be sincere, because he did a really nice speech at the end of his role at the FBI for that role. And very inspiring, and I would totally recommend to see that. It's available on YouTube. And James Comey said that hackers are sitting in infrastructure for 200 days before they are discovered. Some of the other reports say that that number is even higher. So is this a good number or a bad one? I would say it's a bad one, but on the other hand, it's quite a good one, because we learned at least it's 200 days. So it's positive. Of course, it's a lot. Now, is this true? And within our team, we've been doing lots of projects during the COVID pandemic. And actually, I'll tell you that we've seen various situations. One of the drastic situations, one of the drastic projects we've participated into was actually a whole government of a certain country. So there was like the Ministry of XX of a certain country that has been affected by the hackers, and hackers were sitting there as a domain admins for over 9 months. So what did we do? Well, that's like quite a serious case, because then we are dealing with the personal data. What about GDPR and all that stuff? You can imagine the big situation it actually causes. So the police department is engaged, the military is engaged in this project, like everybody's engaged. And then like what you're gonna do? Because you're already like done. Like you couldn't go deeper as a hacker, you got it all, yeah? So the only thing you could do is to encrypt it and then ask for the ransom, but maybe they have a different goal. So what did we do is that we have completely wiped their infrastructure, and we have set up a new domain. But the problem is that if we even set up a new environment, question is, who is doing this? Whose hands are in this environment? Do we trust these people? Yeah, we use the word trust, which is super inconvenient in cybersecurity. So this is another problem that we are bringing, and that is related with trust. So over here, we could also see situations where hackers were sitting like for 3 weeks in the environment, and they have encrypted everything that moved. We've seen situations where hackers were actually sitting for approximately 3 months, and then they also started encryption. We've seen situations where hackers were coming back, and that's even better, because this is actually one of the organizations that are worldwide military-oriented. Hackers managed to get inside that particular company, and they started to encrypt data. Literally started, so they contacted us, and we could see live when it's happening. So we managed to cut them off and then save a piece of environment. And then we said, okay, you guys need to do this, this, and that. And they're like, 3 weeks later, they are calling us again, and they're like, see, this is happening again. It's like, how come? And what we figured is that most probably the access to the infrastructure has been sold on the black market. So, hey, I'm gonna sell to you an environment access for $10,000. You ask for the ransom for like 5 million. It's pretty good business, isn't it? And so on and so on. So this is the time we live in right now, and we have a massive a number of attacks happening within the organizations, and I'm pretty sure you've seen some statistics of how many attacks are happening now versus how many attacks were happening in the past. Now, a little bit more stats, if you don't mind, to give us a mood for what we're going to be showing today. So here you've got statistics that are presented by Asset. And what is quite shocking for me is that, well, okay, we use personal electronic device for work-related functions. Yeah, that's not a surprise. But what is interesting here is that 46% of people use a personal device for work, and they also let someone else use it. So who is that? Kids. Yeah, members of the family. We sit at home, people are bored, people want entertainment, there's only one computer, can I play a game? Okay, you can, and so on. So this is how the threat is brought to the organization. Even though we are not willing to do it, we are able to see that without privileged access management, even from the personal or even work-related device, we are getting access to the environment with some bad stuff over there. So question is, on the top of everything, what kind of things we need to do in order to feel comfortable, and what are these things that we have to invest to from our knowledge perspective in order to feel comfortable? Now look at this, and this is also according to Asset. 27% of people from IT department said that they are not at all confident if it's about the remote work. That's almost 30%. it's quite a lot of people, while 65%, they said they don't have the necessary tools in place to manage non-company issued mobile devices, which is also quite a shocking statistic, because if we are wondering what is the path or threat to bring into organization, that is definitely one of those. So question is, what do we do? Now, what I prepared for you is 6 crucial security skills for 2022. And the reason why I choose 6 is because we could choose 25, but this is just 6 that is the most important one. Yeah. So this is something that for sure we're able to, or we have to learn, we're able to learn in order to make sure we are managing things properly in the infrastructure for the upcoming year. Now, this is based on our team's research, based on our team's experience during the pandemic, and this is how hackers are getting in. So we could even use some reports for creating that kind of a list, but to be sincere, when you look at all of these infrastructures that are experiencing attacks, there are a couple of generic and common conclusions that are coming to our head. And one of these things is gonna be the privilege access management, which I'm pretty sure that you guys are not shocked about it because everybody talks about it. But what I would love to show you is my favorite view on privilege access. And that favorite view is related also with the identity, which we're going to be playing with. But this time, what I would love to show you is how we are able to overtake a certain identity by leveraging the impersonation privilege in Windows, which again is one of the privileges that is assigned for administrators, and that is also one of the ways how we are able to steal identity. Why am I talking about that? Because we've got the possibility to secure identity in Windows box in the workstation by, for example, a couple of ways, like, for example, enabling credential guard. Credential guard technically makes the LSAs to be isolated in a super short words, and therefore if you want to use mimikatz or anything like this, you are not able to do it because that particular API that you were able to use to get the passwords from the memory as mimikatz did, it's no longer available. And a couple of other ways within the virtualization of LSAs and so on. So that's one thing. But what if I do have still privileged access on this workstation, there is a credential guard, you've implemented LAPS, local admin password solution, so you are not able to perform the lateral movement unless you use the impersonation. Like, I found that actually quite unmanaged. So this is something that we're going to be talking about. So, a couple of things to show you. Over here, you can see that I've got a console running as administrator, and there's our tool that's called CQ Impersonate, and there's a CQ Impersonate with SETCB, and there's also a CQ System Escalator. So that's the series of tools that are allowing us to escalate your privileges within the workstation, and eventually you are able to become anybody you want to. CQ System Escalator is actually the tool that allows you to escalate basically to a certain user. So CQ System Escalator, here you've got path to that exe file to be run, and then you are able to run it with some certain arguments, and you are able to escalate to the session ID for the process to be run. So this is also quite cool because it's quite unusual way to demonstrate it. So here I've got 2 users, Freddy Krueger and admin, as you see. And basically in here you can see that we've got the session ID number 2, that's for admin. Yep, and basically we've got a Freddy Krueger, that's number 1. And we will be able to escalate, and also, of course, the system stuff. So here we are able to also escalate into various other operating system processes. So technically, you need to choose whoever you want to in order to be that person. Of course, if this person is logged in. So this is what is important for us to know. CQ System Escalator, by the way, is written by our developer, Michael Grzegorzewski, and this is our team's idea. Yeah, Michael is our dev. So CQ System Escalator, as I mentioned, will allow us to escalate to the particular identity, particular process that you want to. So if you just run it, basically, just like this, just like that, without any arguments and so on, it allows you to become system. So it's a very similar activity to what you got within the PS exec. So let's say that's not a rocket science. And if we do the privileges list, you're able to see that we've got the expanded privileges, which are typical for the local system. For example, debug privileges enabled and so on. Yeah. So here we are able to see that who am I privileges that we've got less. Yeah, so this is basically more on this side. Here we've got local system, and local system also has a privilege which is called setcb privilege. So this is a very old school thing that works underneath of the operating system, which means act as a part of the operating system. It allows you to do lots of things as a hacker. So eventually any escalation to local system will allow you to be acting more or less on the level of a rootkit. Not that much, but similar. So we're going to create here the service. So we're going to sc create test2 bin path, and then we're going to do c windows system32 notepad.exe or whatever. Yeah, it won't start because notepad, of course, it's not written to be responding to scm. And if we go to the services, here we go, msc, then you are able to find that service. So this is our test2, and then you can see that this is the local system account that we are running it on. Yes, so any possibility to modify the executable is also quite possible here. And then we can do the net start, of course, test2, just to demonstrate that basically we've got particularly that that service over here starting, and this is the possibility here to observe that if we do net start, here we go for the test2, then notepad is for the moment starting as a system, of course, because it has been configured like this. So this is another way, very simple though, but still another way to escalate as a user who can create a service. Simply administrator, so whoever is capable to modify the system hive in the registry. So this is yet another way to be able to escalate. Now, what is interesting within these kind of activities is that based on how do we operate with also permissions in Windows, we are also able to hide a couple of things by leveraging, for example, SDDL. You are able to hide the service so that it's not visible in the services that the must see. So this is something that also allows us to perform a little bit of persistency. So all these tools, of course, as I mentioned before, they are all available for you to download at the end. We are using them regularly, by the way, for the pen tests, and this is how I'm able, for example, during the pen test to escalate my privileges, change the account, take over someone's identity, and so on. And it's actually very useful because it's also not detected by the antivirus solutions because nobody really is kind of like treating these tools as an evil ones. Directly, they are not evil. Of course, indirectly, they are super evil if you're gonna use them this way. So this is the possibility that we got over there. Now, if it's about other possibilities, we've got a possibility as well to impersonate. So let's have a look in here at the task manager. We've got over here these two sessions that were established. So there was an admin and there was a Freddy Krueger. So the question will be how we are able, for example, to leverage the one account being logged in and also saving some data here. Yeah, so this is what we're gonna do. So here you've got some secret folder, and if I try to open it, I cannot. So how come? How could it be? So that particular secret folder, we can see that we can go to advanced. There is this checkbox, encrypt content, and Freddy Krueger is the guy who is actually encrypting this data. Yeah. So question will be, how can I get access to the secrets of another user if that's another user who did that? Yes. So here you're able to see that we've got a Freddy Krueger, and even though I can access his folder, his profile, but that would not be the way to do it. And there's also user Mike Raccoons. And that we will be able to leverage. If we want to access, of course, any other user profile, then we just simply can't. Of course, we can take ownership and so on, but still it won't give us an access to that secret folder, and that's the rule of a data protection API that I'm going to be explaining as well a little bit later. Here we've got who am I and the authority system. And the next part, of course, is going to be to get access particularly to this folder. So here we've got these tools, and then we can leverage, for example, the CQ impersonate, and we're going to specify here the parameters for execution. So that's going to be the -u. So that's the user that we would like to impersonate to, and that's Raccoons Freddy Krueger. The next part over here is going to be to specify, of course, how we would like to impersonate. So here we will need to specify that it's going to be -c, and we would like to start the process with this user, which is CMD. So at that moment, this impersonate leverages as impersonation privilege. And that impersonation privilege is allowed in many systems, and technically I've never seen it blocked, so that's the point. And when we look at that from this perspective, here from the regular admin, you cannot, well, you can use it, but then you will need to use it from the local system perspective, because admin does not directly allow you to create these processes. So you can always impersonate the local system and then impersonate as Freddy. And here we've got, even though full privileges, yeah, as you can see, but one of these privileges is impersonate a client after authentication. Yeah, so this is this one. And here you are able to see that we have started a new process as Freddy Krueger without a need of giving the Freddy's password. Why? Because it's impersonate a user after authentication. After. So long story short, here we are able to get into our particularly secret folder that we had. And that was on a Z drive. And then the question would be, are we able to see our secret data? And as you can see, we are. So what is the point is that over here, we can technically open up even notepad passwords.txt, and that's something that opens over here, and we are able to see that we are able to access secrets data of the user just because we managed to impersonate. Now, what's the conclusion out of this set of tools? Yeah, the conclusion is very straightforward. We are here able, when we are someone else, when we are a user, so when a hacker is becoming a user, to access to user secrets on many levels. Now, even though hacker will not be a user, but it's going to be on the computer by leveraging vulnerability where a user is actually logged in, see privileged users, then we are able to take over that identity every single time because of the impersonation privilege and technically be these people, be these users. So if, putting it in a other angle, we've got a user workstation and someone privileged is logging on to this user workstation and hacker is sitting at the same time, regardless if you got credential guard or not, well, if you do, then nobody cares about that because you are able to use the impersonation privilege and you are able to, literally, even in a process hacker, you can do it. Right click on the process that's running as user, run miscellaneous, run as this user, and then you are just becoming that user. It's that simple, yeah? So long story short, this is the possibility that we got in order to actually be a privileged user over here. So what I would love to show you as well, it's the similar situation, but in a little bit of a simpler way when we are technically leveraging over here the process hacker. So here we've got a process hacker, for example, and then we sort by the username. So this is exactly how we're able to use it. So the previous one was more pen testing. This one is more usability. So here we've got a DWM user. That user particularly is, I don't know, like what kind of password it has. Who would know? But then what you do simply, and that's the impersonation clearly, you do right-click, miscellaneous, run as this user, cmd.exe, OK, and then you do who am I, and then you are just this user. That's the point. That's the simplified demonstration. But as a hacker, you won't really use process hacker, but you would rather use some command prompt in a reverse shell. Yeah. So again, allowed in every infrastructure. Is there any mitigation for that? Yes, privilege access management, because you don't really want to get rid of this privilege, because sometimes you do run as certain user. So that is basically what we got. If you guys have any questions, bring it on. Yes, I'm totally open to those. Now, we've got the next part, and that's my favorite because it's a PKI. Certificates, we all love them, and we probably, all of us have PKI implementations, or we all use certificates somehow. Now, the problem with the PKI is that when it was implemented once and kind of left like this, and maybe even it was implemented with the good practices, but the more it lives, the more things we introduce to it, the more templates we use, the more configuration we introduce, and so on. And what I would love to show you, it's a really nice discovery that we made some time ago that happens, as it appeared, very often in various companies, if it's about the template configuration for the web server, or for computer in general. So if you would like to request the certificate for the computer, or for the web server, you have to submit it. You have to submit in the request a name, and that particular name can be misused And this is how we managed to become from the regular user, but being local administrator, to request the certificate for the machine for the domain admin. So in a short words, as a user, domain user, you are becoming, with this request, a domain admin. Yeah, very nice path for escalation, not to be figured during the pen test, by the way. That can be only figured if you do regular configuration reviews of your infrastructure. And this is something that I wanted to jump into. So what kind of things we got? We got over here Bob. And Bob is just that, is just a regular user over there. But the thing is that Bob for here is actually also a local administrator. So long story short, if we do who am I, we can see that we are secure Bob. We do who am I and groups, we're able to see that Bob is a member of the built-in administrators group, built-in users, of course, that's default, and then Bob is just a regular user within the domain, also helpless, but it's not important over there. Now we're going to do the dir DC01 and then C $, and access is denied, because Bob would love to become a domain admin, but that's not possible yet. And let's look up secure.lab, just to give you a little bit of an overview, what kind of environments we've got. And secure.lab, you can see that that's 10.10.10 and 10.10.10.104 for the DC01. Yeah? So this is a very simple environment that we are dealing with. Now, if we do net use Z for the DC01 and C $, then it asks me for the password, and I don't know it. Yeah. So basically, access is denied, and I don't have access to a domain controller, and that's unfortunate because we would love to get this access. So question would be, how can we do it? Let's review these certificates, shall we? So what we're going to be doing right now, first of all, we're going to get into the Cert Manager MSC to see what kind of personal certificates user has. And it's empty. So even though if you refresh it, you can see that there's nothing in particular in the repository. Now we're going to get into request new certificate. Next. And then we're going to request certificates for the user. So we can do that. And at that point, we can go to details. So see here, we have different purposes that are mentioned. So it's a secure email, of course, client authentication, and so on. We could go to enroll, but hey, let's be a little bit sneaky here. What we could do, we could actually specify some common name within the request. It's going to be some tests. And here we're going to specify the user principal name. That's going to be maybe an admin. Yes. So we are checking whether we can submit these data in the request. So that succeeded. We've got some certificate released, issued over there. And then we can get into Bob Builder's details. So here we can see that it's subject, Bob Builder, but we can go as well to the subject alternative name, and that's bob@secure.lab. So that name that we were looking at, it's not populated. So it's all secure. So it's all good. We could not submit that data in the request. So we can delete it. Okay, and then the next part is going to be related with getting into the certificates of the machine. Yes, so user, it's not that interesting. We're going to go into, at that point, cert, and then for the machine, so lm.msc, so yes, and that's why we need to be local admin for that. So here, we're going to go to the personal certificates, and there is something, yes, as you are able to see. We've got the site 1, site 2, whatever, yes, so the classic stuff. All tasks, request new certificate, next, and then here, this is what I wanted to show you. We've got it here, CQ Web and CQ Web Bad. Bad means the bad one, obviously, but I would like to show you the difference, how and what kind of mistakes people make when they are allowing these certificates to be requested for. So if you go to the details, here you see that there is a digital signature, all the details, but what we see is that server authentication is one entry over here, and in the bad one, there is also client authentication. And that client authentication is obviously a bad idea. Now, the problem with this certificate template being seen in vast majority of organizations when that template is available, unfortunately, then we are able to submit the name in the request. So the problem is ready. Yeah. So that particular Bob user will be capable to submit additional data into that certificate, to put that data, and then eventually maybe request a certificate as a domain admin. Let's see, of course, about that. So we're going to go, of course, to the properties of this one, and within the details, we're going to specify details for the client authentication. So here, let's just go crazy a little bit. We're going to specify the common name, and then we're going to do site3 secure.lab or anything like this. So this is like normal, yeah? So, and here though, we're going to add some additional data. So there is a DNS field as well that we are submitting site3 secure.lab. So everything here is all good. So that certificate, by the way, does not look suspicious in the logs as well. But here we're going to also add user principal name, and then we're going to add admin@secure.lab. And then we're going to do add. Yeah, so here we go. Let's just apply that. Okay, and then the next part is going to be enroll. And unfortunately, we've got success, but of course, it's not really assured that we're going to have this name underneath or not, but we're going to verify on that, and then you guys are going to see that eventually that admin name has been actually populated. So that's the site3 secure.lab that we have requested for. It's available within our certificates for the local machine. And then we can get into details of this guy, and then we will be able to verify what is inside. Now, what is quite unusual over here as well is that, as I mentioned before, in logs we are able to see the site3 because it's issued to site3, all is good over there. But then if you go to the subject alternative name, here we go, admin@secure.lab. So that's awesome because we may try to authenticate with that certificate, and let's see if that works. So what we're going to do, we will actually export that certificate because we will need to actually get it submitted into our user. So it has to be used in the user context, but right now it's in the machine's context. So we're going to go into export, and at that point, yes, export the private key. Even, by the way, the private key was not exportable. It doesn't matter because it's in the memory anyway, so you can extract it from the memory. So these two radio buttons are really useless. So you can always export the private key. That's the thing. Next. And then we are exporting it to the classic old school PFX format. We can give it a password, so we can type in whatever password. Yeah, it doesn't really matter right now. Then next, and then browse, and then we are just saving it as FC5 or something. Yes, so we're gonna do it save, and then we are saving it in our local repository. From here, we don't need it anymore because machine won't authenticate as an admin. So the next part will be related with actually at that stage importing that to the user. Yes, so we would love to, at that point, be able to authenticate as an admin. Now, it won't be that pretty, I will assure you, but let's see, of course, what kind of possibilities we got. So first of all, here we're going to just choose the DG folder and then this FC5. Of course, we can put in the password, yeah, and then next, finish, and then import was successful. So we've got over here our site3 secure.lab certificate. So this is something that we're going to be here trying to use. Now, the best part is that we've got a possibility to authenticate with the smart card. If we do the run as, and if you do run as question marks, here you've got the smart card certificate. So use of credentials are to be applied from the smart card. Yes, that is what we want. That is exactly what we want. So the next part is that we're going to delete that certificate because in order to authenticate with the smart card, we need to have a smart card. So let's first of all generate here a smart card. So we're gonna set up a smart card reader where we're gonna submit that certificate. So let's go into the device manager. So here we go. And then over there, we're gonna be adding it. Yes, so this is something that, as you can see, we've got security devices. There isn't much. So we will need to specify that smart card to drop in inside that certificate. Yes, so TPM, virtual smart card manager. And within the question mark, we can use the defaults, yes? So please don't judge me by the defaults. Of course, we should not do it this way, but let's do it quickly so that we can see whether it works or not. Yeah, so here we've got a default pin, 1, 2, 3, 4, 5, 6, 7, 8, and that will be it. So here we go. And then we've got here basic session. So we can, within the hypervisor, try to log in as Bob Builder again. So let's do it. So we're gonna log in. And eventually here we will need to generate it again because of the terminal services session. And then the next part, it's going to be related with, of course, using this particular smart card. So here, if we do technically refresh, you can see that we've got a smart card readers. Yeah, so we've got a My Virtual Smart Card. And at that point, we're going to generate one more thing. So that's going to be the import PFX into the smart card. So we are using here the Microsoft-based crypto service provider. So here we go, smart card crypto provider. And then we are using the FC5 that we are importing into the smart card. Yes, we have to elevate for that one. So let's do it. So cert util, we will need to run with the local admin privileges. And for that one, we will need to elevate. Let's do it. And eventually, here we can run the PFX password, so the one that we were setting up before. We're entering the PIN for the smart card reader. And eventually that, after a while, because it takes a moment, our certificate's gonna be loaded and, as you see, added to the store. So right now, it's pretty cool because we've got a smart card in the store. If we refresh it for the current user, it's there, so it came in, so it's all good. Now the next last part, it's gonna be, of course, to verify whether we got access to the DC01 $, and then as you can see, access is denied. Why? Because we are not using that certificate yet. So this is the setup. We're going to use over here the net use, Z, and then DC01, and then $, and then here we're going to specify again password, but again, we don't have it, so we have to use some parameters for the logon. That's the point. And there is a switch for the net use. It's called smart card, and it automatically reads a certificate from our smart card. So you can see that we are obviously reading smart card. And the next part, it's going to be, of course, most probably the access to the domain. So let's put the PIN in. So we are specifying that one. Okay. And then eventually command completed successfully. Let's verify if, using this feature, Bob is capable to enter Z, and then dir. And we are right now a domain admin. Yeah. So here we can go to Windows, NTDS, just to confirm that we are within the ntds.dit. And as you can see, we've got full access as a domain admin to the environment. Again, is this discoverable during the pen test? No. It is only discoverable during the smart config review of our services. And that is also, by the way, one of the common mistakes that companies are making during their PKI implementations if they are having a certificate template to be used for the web server. Common thing, sincerely. And we are also kind of ironically laughing in our team that when we are doing the pen test and we are always asking ourselves, how did you manage to get in? And everybody's like, haha, during the same thing like this one. Yeah. So it's also quite funny to see that. Okay, guys, so this is one thing. Conclusion, what's the skill to gain for the 2022? And is to review your identities and how we are leveraging our identities, how we are using certificates, who can request for them, with what kind of possibilities, because as I mentioned even on a previous session, identities are more important than ever. So skill number 3, forensic analysis and data log extraction. Ooh, this is what we could talk about for a long time. Because how many times we've been into the situation where there is an attack and companies are struggling. I'm sure you've seen it. Yes, not maybe in your environment, maybe in someone's environment, but the companies are off for quite a while and then they are slowly coming back to the operations. Why is like that? Because of the poor maybe backup strategy, because maybe poor incident response planning, many situations. Do you know what's the common issue that I've faced while helping customers with the incident response? You have to do the memory dump and you have to do the disk dump in that order, yeah, if you want to collect the evidence. And also a couple of other things, but these are the major steps, let's say. So I say that over the phone because they call and then I'm like, okay, you need to do the memory dump and disk dump. And they're like, oh, okay, so how much space do we need for that? Well, how much memory you got plus how much disk you got, that's how much space you need. It's like, oh, but we don't have a drive like that. So what do you want to do? Amazon, 2 days later, because we in Europe do not have this kind of quick shipments, yeah? So we have to deal with this. So then next day or maybe the day after, the disk comes, or a second question is like, okay, so hold on a second, I have to clean it first in order to make a dump. And the time is ticking. Yeah, so this isn't it funny, right? Like we are dealing with the company's security, but then they complain that they don't have enough space on the drive. Oh, sorry, I have to delete these movies or whatever I got over there because it's like the drive that I use for everyday's cases, yes? So again, like incident response readiness equals preparation in a pacetime. So we have to have USB sticks with tools. We have to have a pile of disks that are allowing us to respond fast. We need to have a team that is set up in a case of emergency. And that is something that we've observed that companies are not really managing very well. Now, regarding the skill set, what I would love to show you, it's an interesting perspective. So this is something that basically we've been dealing with our customer. Here's the story. All of these examples are real life. Here's the story. There is a factory environment. Also, by the way, they have a location in the Netherlands. But it wasn't happening in the Netherlands. There is this guy, cool guy, don't get me wrong, he was cool. But he was really bad because he was actually sabotaging the infrastructure. He was putting the components of the infrastructure down. So this factory environment, they were like, what's happening? They had 3 domain controllers and he put all of them down. Well, I already spoiled it. So he was the one who was doing this. And then eventually, he was coming back all in white and he was like, I'm going to fix it for you. And everybody was treating him as a prince because, you know, he knows and he's the god and he is the one who can fix the stuff. So, like, definitely he deserves the salary increase, and they were completely treating him as the admin, you know, with the with the capital letters, admin with the capital letters. And unfortunately, someone thought that it's a little bit suspicious that this guy knows how to fix it in such a quick time. So we came in under the cover of doing the Active Directory health check. So this guy was happy, you know, he was cheering up. He was actually saying welcome by the door. He was like, hi guys. And I was like feeling obviously horrible inside because you are lying to him. Yes, that you are not doing the Active Directory health check, but you are just here to fire him. You just need to find a reason, yeah? To be fair, I mean, isn't it fun job at the end? But brutal, right? But anyway, yeah, and this story, of course, it's a long story, but what I wanted to tell you is that we were actually spending the night over there, and I managed to sneak into this guy's desktop computer, and it was locked, but through that, it was some time ago, through the FireWire that was available before, you were able to do the direct memory access, which Windows 10, by the way, right now blocks, and that's good and bad at the same time, depends on the project type. For security, obviously, is good. So what I did, because this guy was literally cleaning up the evidence after himself, and what I wanted to do, because he was cleaning up also the event logs, I wanted to check if in a memory, because he cleaned the event log, there were left events that I could use in order to find some traces. But the problem was that there at that time there was no tool to do it. Because EVT from Windows XP, that's old school. I mean, everybody can edit it and so on. EVTX, though, from Windows Vista Plus, it is actually one big, good piece of file. There's like lots of internal digital signatures inside. You can still change it because we figured how to change it inside, but it's a lot of work. So you can trust EVTX in general, yeah? So my job was to extract it from the memory. So question is, how can you do that? And one of the things that I was doing over there is that within the volatility, which is the memory analysis tools, I was able to extract some information from the memory dump that I made. Yeah, so you do the memory dump and then you leave. Yeah, and over there, what we were actually using was his profile. So in this case, we've got to analyze.dmp as a memory dump, and at that point, we're gonna be extracting data, of course, from the event log service, which I will tell you how, because it's also quite sneaky. But at that time, we will need to specify the profile. And for this one, it's going to be the Windows 7 SP1X64. This was this time, by the way. And then the next part we will need to do is to identify technically the Windows Event Log Service. Windows Event Log Service is SVC host. So if you see the list of SVC hosts, question is, which one of those is this? And the answer is going to be the one that probably loads the DLL that indicates the Windows Event Log Service. Okay, so we find out the DLL and we learn that's the WinEVT SVC. So we're gonna do that, but first let's find it, yeah? DLL list, that's the module that we use within the volatility, within the memory dump, and then DLL list.txt, enter. 20 seconds, we're going to be checking for that one. And the next part is to, of course, extract that data. So DLL list, okay. And then over there, we can search for the WEVT SVC. This is this one. So we found it in the bottom. That's the process ID 848. 848. Okay, we remember that one, 848. And then over there, we're going to do dump files. Dump files. And then we're going to, first of all, maintain the names. And we're going to use the process ID 848, was it? And then we're going to do the dump into files. I think I should have a folder like this. And then we are dumping right now from that particular process in the memory the files that this process had handles to. So technically, SVC host is managing, we can stop it already. SVC host is managing files, even log files, and we want to dump them. So whatever is in the memory we are having right now. Okay, that's awesome. So let me show you this one in GUI right now, because it's going to be a little bit more convenient, I think. So we're going to go to the Python volatility master, and then we've got the files, lovely. And that's this list over there. That's this one here. And let's just do it this way. And then from this list, we're going to be extracting the application log. Why? Because it's the most juicy one, yeah? And we could be doing system. The application is good too. So I'm copying this. I copied that one. And I'm going to put it into my tools folder. Why? Because this particular log, by default, is actually not readable. And what I wanted to show you is a really nice way to fix EVTX. So if you're ever going to be in a situation with the EVTX being corrupted, then basically use our tool, because it works like a charm. So here, please have a look. That's this file that we copied. And I will just rename it file of, it is from VACB to file without a VACB, just to show you that it won't work. Yeah. So file, we are firing it up right now. And then it opens even log. And as you see, file is corrupted. Yes, okay, so that's not a good situation, obviously. So let's fix it. And we're going to fix it and put it in the out directory. This out directory is empty, as you guys are able to see. Let's clean it. And then the simplest fix ever in this world, CQ EVTX recovery in folder, out folder, enter. That's it, done. So we're going to go to the out, and then we've got our file. And we will try to open it. And then it has to verify the digital signatures, blah, blah, blah. And then in a moment, it's going to actually show you events. It said 17 chunks. Chunks are different than events. We've got here events that are consisting of chunks. So this is how you fix EVTX. Now, this is a forensic skill set which has to happen in the organization, because how else, if not this way, we're able to quickly react. We can, of course, outsource the services to an external company, and this is what the companies are doing, but the first reaction has to be done by us. It's going to be the case of 2022, sincerely. Now, malware analysis. Just to mention, yes, because not everyone wants to jump into this particular sphere. If we've got a code that we don't know, question is, what kind of skills we got in team to analyze it? Sometimes companies are like, whatever, we just wipe it and then we don't care. But sometimes you may want to jump into it. So just to put that skill on the grill, so that this is also one of the things that we should be reconsidering over here. Another one, effective whitelisting. So again, this is something that Sami was also mentioning regarding how important privileged access workstations is. And again, I was mentioning also on the previous session, but of course, not everybody was there, regarding the effective whitelisting. And why do I use the word effective? It's because we deal with PowerShell, we deal with certutil, lolbus, lolbeans, living of the land libraries. We deal with, for example, C-script. So all these things that are built in Windows that technically we have to block in order to achieve a good status of security of the workstation. And the last skill, so the number 6, is understanding identity. And why do I keep it as the last one? Because it's actually the most important one, in my opinion. Because, let me show you something. In here, we've got, again, our favorite Freddy Krueger. Let's log in as this guy. And we are logging in with the password. Okay, so that password in here, we've got technically, we are just, everything is normal here, yeah? We are logged in over there as regular Freddy. And we're gonna go to the Chrome pass to display that Freddy has actually stored password in a Google Chrome. Yeah, so this is the situation. Okay, now question of the universe would be, if I'm not Freddy, so let's be not Freddy for the moment. If I'm not Freddy, am I able to get access to the Freddy's password? And according to the data protection API, as we know it, answer is no. And we're not supposed to, but there is a bit of a problem. And let me disconnect this machine from the network because I would like to log in with the cache logon data. So not connected, okay. And over there, repair your computer. We're gonna be troubleshooting, advanced options, command prompt. You could obviously do it online too. You can do it offline or online. I'm gonna do it offline because it's more straightforward. So here, bigger font. I'm gonna go to the D drive, CLS, CQ tools, and this time it's gonna be Kiwi Secure Edition, known to you Mimikatz, but Secure Edition, this is the edition that's not recognized by antivirus. LSA dump, cache, and this is actually our module, so Windows System 32 config. Let me just make it a little bit bigger. It's going to be not very convenient, but anyway, we will survive that. We've got a config system, and then it's going to be the Windows System 32 config security. What are we doing right now? We are overriding the cache logon data. Some people call it cache credentials. Don't do that. These are not credentials. We should call it cache logon data because we cannot log on with these credentials not being credentials. So it's just technically incorrect. Anyway, done. Continue. So we have overwritten cache logon data, and we are able to log in right now as domain user Freddy, but with a different password. All right? So this is in order to prove to you that we will not be able to get access to our passwords. So that's the password. And it's not working. So Mimikatz, it's what we have overwritten over there. Mimikatz, enter, and then we're going to be log in as a domain user with a different password. Now, the most important thing on Earth right now is to check whether we can get access to the user's credentials, and you will see that it's impossible. That's the good news. Yeah. So if someone else is on our computer, then we are not able to get access to the credentials of this user unless this user is logged in. We already learned that within the first skill. But what about domain admin? That's my favorite drama story here. What about domain admin collecting information from the profile and then leaving? So can we get access to secrets of all of the users within the organization? Yes. And this is a beautiful thing to have, because within the domain admin, we are able to extract the certificate, and this is our team's discovery. So to be fair, this is our reverse engineering for the DP API. Here you can extract from the domain, so CQL's secrets dumper, the file exported PFX. This is actually stored as a data blob in the ntds.dit, so you are not able to see it among certificates. And exported PFX, next, password is secure, next, finish. I'm just gonna import it so that I want to show you how it looks like because it's actually pretty cool. Cert mgr.msc, that certificate being not available over there, it's something that each of you guys have in your domain, you want it or not. And it's generated from the moment you have set up your domain for the first time. Now, every question you ask right now, answer is no. And we can continue. Can I renew it? No. Can I get rid of it? No. Can I fix this? No. Can I upgrade it because I'm changing the functional level of my domain? No. The only thing you can do is to set up a new domain on the side. That's your fix. So when your domain is hacked, I don't want to swear on the stage, but you've got a problem. Yes? So long story short, this is something that you cannot fix. So when your identity, this gets compromised, there's like a list of 40 steps to do once your domain is affected. Okay, so you change your password, you change the KRBTGT password, blah, blah, blah. You change the KDS root key, all that stuff. It's beautiful, but this one, no. So it means that your domain will always remain compromised and your users will always have a possibility for the passwords leaking. And I would love to show you this, of course. So this is a very short last thing to demonstrate where we're gonna do, first of all, one thing. We are right now on the user's computer, yeah? So CQ tools, DP API. First of all, what I will do, I will calculate the hash on the top of the current user's passwords, which is wrong. Cats. I need to have a correct one, obviously. That's this one. Okay, awesome. Second thing that I will need to do, I'm just gonna keep it on the side, is related with, obviously, getting into one thing, learning what kind of, we call it master key in the workstation, is responsible for protecting the passwords for Google Chrome app. And in this case, we're gonna use the CQ DP API blob searcher. To be fair, this is my favorite tool amongst our tools within the team. I'm loving it. Forensically, awesome, because it searches you for all the data protection API blobs, so all the potential password stores in the workstation, like super useful. And then we're gonna do directory over there. C, users, Freddy Krueger, here we go. Then app data, let me move it to the middle. And then we've got the next part, which is of course local, then it's Google, then it's Chrome. Or we're gonna go directly to this folder to speed it up a little bit. And then we do the recursive search and output into C CQ tools, and we're gonna do the stream into dpapi.txt. So what this command does, it says, show me all the possible places where Google Chrome stores passwords. So we go to the dpapi.txt, and what we see, it's, oh no, Google Chrome uses Chihuahua and triple des underneath. Just saying. If you ask me personally, I don't use Google Chrome. And that's for this reason. It's not that it's bad, because Chihuahua is still approved, security-wise, even if we know we should get rid of it, it's still approved. It's just like when someone drives a pink car on the street, would you trust that person? I won't. Yes? Not that pink is bad, but sometimes you've got your views on the stuff and you're like, nah. If someone makes a decision of using Chihuahua underneath and that's Google Chrome, don't use this. Yeah. By the way, Edge uses the Schwa 512 and AS. And I'm not saying it's better. It's just that it uses a different cryptography underneath. You get into your own conclusions. So the next part is to actually learn that there is actually the master key. So that's this B55 that we're going to be touching base on. And that master key set, they are stored in app data %, app data roaming, Microsoft, protect, SID, and then we go to the B55, and then that's this one. So shift right click, copy as path. We're almost there. The next part is to leverage that one. So what we're gonna do, CQ master key AD, we're gonna actually do file, put this one in. We're gonna do decryption by using this certificate from the domain. We are doing this on a user workstation, please notice that. And then we're gonna do new hash. And then the next part is that we're gonna copy over there this hash from the Mimikat. So we are decrypting the master key that we could not get access to, that could not give us a password, with the certificate from the domain, and encrypting it with our new password hash, because that's how it works. Enter. Almost done. Literally the last part, which is related with renaming this master key, because we don't need it anymore. So I'm just gonna rename it, not remove it. Let me rename it with the end underscore good, something like that. And then this AD modified, rename, and we're gonna do it like this. One last step is to give it an attribute of a system and hidden. Enter, place, awesome. And then this password was not visible before, it's visible. Yeah, so what it means that your domain admin, whoever it was in the past, for the whole years how your company was in the market, whoever was a domain admin, from the moment your domain was set, is from that moment always capable to decrypt user's secret for every organization. So if you work in a bank where you got like 100,000 users and there was a domain admin in 2013 and this person is no longer working there, this person still has a possibility to decrypt every single employee's password in your organization. It's not a very positive scenario, isn't it? So long story short, the reason why I put the understanding identity is because with this approach that we have just demonstrated, I cannot use the other words like our infrastructures are just in a permanent compromised state. And I don't want to make any drama, but if someone was able to extract that certificate, so any domain admin simply, then from now on, ever and ever, this person would be able to get access to your users' data. Of course, we might be like, yeah, but this person first needs to get access to infrastructure. But what if this person, so domain admin, at the moment of leaving the company, copied all of the profiles and users store passwords in a browser? That's what I was proving. So then this person is able to extract passwords for every user to Facebook, LinkedIn, and so on, and do my favorite scenario, which is very vicious, don't get me wrong, of public shaming. So then this person is going to write like, oh, in this company they do harassment. Which is not true, but it's a beautiful way to destroy some company's reputation, and so on. So again, imagination is yours, but what we should do in order to fix this problem is that A, we cannot fix this problem, B, I only bring the bad news, sorry about that, is that we cannot fix this problem. Second, the only thing we can do is to monitor our identity. Yeah, so how privileged access is used, where it's used, when it's used, is there any anomaly? So anything intelligent on the top of that applied is something that we have to work on, guys, because these kind of things are becoming more and more popular, and knowledge about IT security is also becoming more popular, so why not performing these kind of attacks on the bad side? Now, CM systems, of course, are on the rise to correlate activity of identity. Also using multi-factor authentication, it's not as bad as I was presenting on the previous session. It's still the case, but we have to surround ourselves with either conditional access or some intelligent monitoring of an identity. Also, playing with the skill gap, which is also a subject that is never ending, that the more we train our personnel, both in IT and also employees on security, we all know the better, yes, but there is a real need for that nowadays. And remote workforce is bringing lots of threats to the inside, also related with identity and code execution, so we need to be technically ready in order to respond to an incident, and that is basically this little 6 things that I wanted to show you. So we talked about basically the need for the privileged access management. We talk about the PKI and in general services misconfiguration. We talk about the forensic, so the incident response plan and the incident readiness. We talked about the malware analysis and the need for that, as well as effective whitelisting. And we talked about the understanding the identity. So these are, in our team's opinion, the most needed skills for that 2022. Not too bad, isn't it? So if you would like to use the tools that I use within the session, please go ahead and download those. You can take a picture. This access is, of course, for you available, and also the DP-API tools, so including the DP-API blob searcher, all of them are free. And yeah, please just use them. Of course, they're very useful also from the forensics perspective. And the next part is that if you would like to check out our blog is this one. So hopefully, of course, we're going to as well stay in touch. And my email is absolutely simple. That is paula@secure.us. So hopefully, of course, we will see each other next year. And thank you so much for attending the conference and mainly this presentation.